Hello everyone, welcome back to my YouTube channel Unfog with Dr. Atahar Parveen. In this session, let us start discussing on electromagnetic radiation from your HSTR syllabus. I have divided this chapter electromagnetic radiation into 3 parts. That means I will take 3 classes to finish this chapter, and this is your first session of this chapter. I have underlined the portion which I am going to cover in this class. Okay. Now, firstly, let's talk about what is electromagnetic radiation. See, electromagnetic radiation means it is just a fancy way of talking about light waves. However, this is not normal light. Actually, light comes in many forms. There are a lot of forms of light. All those forms together put in, we call them as electromagnetic radiation. Now, we all know that light can act like a particle or like a wave, right? But most commonly it acts like a wave. Now let's talk about the light wave. Light wave, it looks like this. It will have crest, it will have trough, and that light wave, it will have a wavelength, and also it will have energy. First, let's talk about wavelength. What is wavelength? Wavelength means it is the measure between the distance of 2 troughs or 2 crests. This is one definition for wavelength. If I want to explain it in another manner, then wavelength, it is nothing but the distance of one full cycle of the oscillation or one full vibration of the wave. Okay, that will be the wavelength. It is denoted by lambda. And this wavelength, it is related to the speed of light and the frequency of light. Okay, let us discuss what is frequency and all that. But here just I am giving a gist that wavelength plays a very important role because it is directly related to speed of light and frequency of the wave. Now, because we are talking about the distance, then the unit of wavelength will be in meters. Okay. Now, the time taken by this wave to travel for one wavelength is known as period or time period. It is denoted by T, and because we are talking about time, its unit will be in seconds. Okay. Now consider a wave. In this wave, you have certain distance in x-axis, right? And certain distance in y-axis. Now, this distance from the middle of this wave, that is from the x-axis to the maximum vertical displacement, that is on the y-axis, that distance is known as amplitude. You can see here, this is known as amplitude. Okay. This amplitude is also very important when you talk about a wave, because this amplitude will tell you about the brightness or intensity of a wave when you compare it to other waves. See, if a wave, it has more amplitude, it means that it has more brightness or it has more energy. If a wave has less amplitude, then it means that it is having less brightness or less intensity or less energy. Okay, so you can give the character of a wave when you know the amplitude. The symbol for amplitude is A, and because we are talking about distance, the unit will be meter only. Okay. Now let's talk about frequency. Here, this is one vibration, right? One vibration or one oscillation. Then this one will be second vibration or second oscillation. Now these are number of cycles, right? One vibration is one cycle. Second vibration is second cycle, isn't it? And it will go on. This wave will be with many n number of cycles. That number of cycles that are occurring per second is known as frequency. The symbol for frequency is mu, a Greek letter, and the unit will be either, you can tell that the unit is hertz, H-E-R-T-Z, hertz, or per second. Okay. This frequency is also related to energy. Here you can see that E is equals to h nu, the well-known formula given by Planck. Here E is energy of the wave. This energy is in joule. H is the Planck's constant. The value of this Planck's constant is 6.62 into 10 raised to minus 34 joule second. And nu is the frequency, of course. So for any wave, the energy of that wave and frequency, they are directly proportional to each other. Now, you can also relate frequency with the time period and frequency with wavelength. How do you relate it? this frequency, it is inversely proportional to the time period, or you can directly say that the frequency of a wave is the reciprocal of the time period of that wave, and it is also inversely proportional to the wavelength. That means the wavelength of the wave and frequency of the wave, they are inversely proportional to each other. You have to remember all this. You never know, they can ask any MCQ from any point, isn't it? All these points are very important. I am making the class as short as possible because I don't want to waste your time. I am putting all the important points here. I am making sure that if you watch my lecture, then you are good at this chapter. You don't need to read this chapter again, or you don't need to search for material from this chapter. Okay, just watch this video and make notes, then you will be perfect with this chapter. I assure you that any question coming from this chapter will come from this class only. Okay, means I mean to say the first part, the second part and the third part. If you watch these three parts, then you will be perfect with electromagnetic radiation chapter. Okay, both for HSTR people and CRISE people I am telling. Even TET, Karnataka TET, all those aspirants also. Okay, I am choosing all the important points. I am excluding the non-important points. I am not adding here because I don't want to trouble you all by giving long classes. Okay, coming back to our class. Now we talked about wavelength, amplitude, frequency and time period of a wave. This wave is moving, right? Then it should have a velocity, which is a very important part of describing the wave, isn't it? Now what is the velocity of a wave? If the time period is equal to 1 second, then distance traveled by the wave in 1 second will be the velocity of the wave. And the units will be normal, which we use in kinematics. That will be meter per second. Okay. Now let's have a glance on all the units. Amplitude, meter. Velocity, meter per second. Wavelength of a wave, it will be in meters. Time period, it will be in seconds. Frequency, it will be in hertz or per second. Okay. Now the velocity of the wave or velocity of the light is the product of wavelength and frequency. This you have to remember. C is equal to lambda nu. This is a very important expression for us. And also one more very important point is that the speed of the light is 3 into 10 raised to 8 meters per second, and this is always a constant. Okay, actually there are some decimals, 2.9 something, that round figure will be 3. That's why I am giving you 3. The speed of light is 3 into 10 raised to 8 meters per second. Now we are discussing about light since we started the class. But do we know from where these light waves come? These light waves, see, one of the best source for light waves is sun, right? And of course these light waves also belong to electromagnetic radiation. This electromagnetic radiation, it will involve two objects. If I take example of a sun which is giving me light, then it is giving me light, right? The light rays falls on me, or the light rays falls on earth. Then there is the interaction between two bodies, right? Now the sunlight or the normal light, it does not require any material medium to move, isn't it? It can travel through empty space or vacuum. Now once the earth gets light rays, then earth will absorb it and it will reflect back. Okay, but then the reflection will be very less when compared to the actual light rays which are coming from sun. So this is one important point. I am giving you this example because we can relate to light very easily, right? We cannot relate to other electromagnetic radiations very easily. That's why this is the time I talk about light. Then we can proceed with the electromagnetic radiations. So I can say that the electromagnetic radiation, it is nothing but flow of energy in both directions. That means there is an interaction between two bodies. Now this radiation, it has different forms and different forms of different type of energies. Now these could be gamma rays, X-rays, UV, visible, infrared, microwave or radio waves. These all put together, we call them as electromagnetic spectrum. And these radiations, all radiations are known as electromagnetic radiations. In this, visible light is also there. Okay. Now when I tell that all these radiations have different energies in different forms, I can give you a best example. If a wave, it has high energy, it can penetrate into our bodies. What are those rays? Those rays are X-rays, right? If you just put a torch on anybody's body, does the body become transparent? No. Can you see the picture inside the body with that light? No. This can happen with X-rays. If you allow X-rays to pass through a body, then you can see whatever is there inside. The inside bones and all those things you can see. That is because the X-rays have more energy when compared to other radiations. Okay. Now, we talked all about from where do we get light and all that. But how is light created? Now leave the sun apart. Don't think about the sun. Just in our common layman language, what do we say? How the light is created? Light is created by charges, right? Those charges, for best example for the charges we give is electrons. How do they create this light? The electrons, they change energy states. From one energy state to another energy state they jump and they emit light. This light we call it as a photon. Why does this happen? This happens because of conservation of energy. Any atom energy will not be increased just because the electrons are jumping. To maintain that energy, it will give out the photon. Okay. Now what is this photon? In simple terms, we say that it is a packet of light, or you can also simply say that it is a single wave of light. Now, if this charge or electron, it changes its direction, then also energy will change. Okay. First is if it jumps from one orbit to another, it will give you photon. Or if the charge, it will change its direction, then also the light energy will change. Now it will become easy for us to understand electromagnetic radiation. Like what are electromagnetic radiations, how they are created, what are their uses, what is their speciality, what are their properties and all that. Okay. So electromagnetic radiations, as I told you earlier, it is a form of energy. And how is it produced? These radiations can be produced by two ways. One way is that the electromagnetic radiation can be produced by the movement of electrically charged particles which are traveling through matter or vacuum. The second way is that just by oscillation of magnetic and electric disturbances, you can get electromagnetic radiation. You can see this picture. This is the best picture which portrays the electromagnetic radiation. Here you can see that there are two types of disturbances. One is the electric field, the other is the magnetic field. Now this magnetic and electric fields, they come at 90 degrees to each other. They combine together, they move together, but they are perpendicular to each other. Okay. Now how does this electromagnetic radiation occur? It occurs when an atomic particle like an electron, if it is accelerated by an electric field. That's what I told you, right? If it jumps from one orbit to another, then it gives you electromagnetic radiation. Okay. Actually, in older days, no, this magnetism and electricity, they were considered as separate forces. No one even imagined that magnetism and electric field together, they may be moving. Okay, that wasn't there in anyone's imagination also. But when this electromagnetic theory came, this was given by Clerk Maxwell. He gave this unified theory. He told that there are magnetic poles which can come in pair, like the electron and proton, or the positive charge and the negative charge. The same way, the North Pole and the South Pole, they can come in pair. They can repel and attract each other, just like the electric charges. He also told that an electric field, if it is moving, then it can produce a magnetic field. And for example, you take a wire with an electric current, it will produce magnetic field, but the direction depends on the direction of the electric current. Okay, the magnetic field and electric current, they will be perpendicular to each other. Now consider this wave with amplitude, wavelength. We all talked about it, right? Crust and trough, and the x-axis which we were talking about, let us put it as time. That will be time. Now we can talk about the properties of electromagnetic radiation. First is that they are perpendicular to each other and they have few characteristics like wavelength, amplitude and frequency, which we all talked already. Then another important property of these electromagnetic radiations is that they can travel through empty space. Why are we mentioning this empty space particularly here? Because there are many waves, right, which do require the medium. For example, the sound waves. They cannot travel in empty space or vacuum. They need some medium, okay? And the speed of the light is 3 into 10 raised to 8 meters per second, and it is always a constant. So these are the properties of electromagnetic radiation. Now all these electromagnetic radiations put together, we call it as an electromagnetic spectrum. We used to call a spectrum for white light. Remember the whipwire? That is a spectrum, right? The group of the lights. In the same manner, the group of all the electromagnetic radiations we call as electromagnetic spectrum. It is the range of frequencies with electromagnetic radiations and their wavelengths, their energies, and all that we can write in that spectrum. These electromagnetic radiations, they consist of gamma rays, X-rays, ultraviolet rays or UV rays, infrared rays or the IR rays, radio waves and microwaves. Okay, we have the visible light also in this. And these radiations, they have a wide range of frequencies, wavelengths and photon energy levels. This we will have to learn. Any question can be asked from that frequencies, wavelength and energy levels. And as I told you, these also travel at the speed of light and they can travel through vacuum. Now here I have a picture which portrays the size of the waves. Here I have the wavelength. Here I have the size of the waves. See, the visible light is in the middle of the spectrum. In its right side you have ultraviolet, X-ray and gamma rays, and the left side you have infrared, microwaves and radio waves. Here you can see that the gamma rays has the least wavelength. The smallest wavelength is of gamma rays. It is around the size of the atomic nuclei. It will be around 10 raised to minus 10 to 10 raised to minus 12 centimeters. Then for visible light, the wavelength is 10 raised to minus 5 centimeters. The radio waves have the highest wavelength, you can say. It is about the size of the building. Okay, that you have to see. The wavelength is very big for radio waves. And the ultraviolet rays, they are up to the size of the molecules. Okay, so these are all the sizes which they have given to relate. You have to remember these values. I'll help you remember this. I'll talk more on this. Now, as I told you, the radio waves, they have the highest wavelength and gamma rays, they have the lowest wavelength. Remember, I told you that the wavelength and frequency are inversely proportional, right? So when I say that the radio waves have highest wavelength, I mean to say that the frequency of radio waves is very small. When I say that the gamma rays have very less wavelength, I mean to say that the frequency of gamma rays is very high. Okay, and here we also have the visible light in the middle. I am giving you the applications here because in your MCQs many times in HSTR they are asking the applications of each electromagnetic radiation. For example, for visible light, it makes things able to be seen. Means without light you can't see anything, right? So that is one application for visible light. Then ultraviolet light, it will be absorbed by the skin. It is used in fluorescent tubes. It will cause tanning. People become black, when they are in sun. That is because of ultraviolet rays. Then X-rays, they are used to view inside of bodies and objects. This is because they have the higher energy. You can use this E is equal to h nu formula here to remember the energies. More the frequency, more will be the energy. The frequency is less right here for gamma rays, so energy will be more. For X-rays, it is little bit less, right? So other than gamma rays, X-rays have the more energy in the spectrum. Like that you can relate. And then gamma rays, they are used in medicine for killing cancer cells. And infrared rays, they transmit heat from sun, fires, radiators, and they are also absorbed and re-radiated by greenhouse gases. This was a question asked in your previous year HSTR exam. And then microwaves, obviously, of course, they are used in the microwaves, right? You use them in the microwaves to cook food or to heat the food and all that. And then they are also used in radar and telephones and other signals also. They are also used in the satellites also, satellite communications and all that. And then radio waves, they are used in broadcasting. This is the main use of radio waves. They are used in broadcasting in radio and television. Okay, so these are the applications. And here I am giving you table of the wavelength and frequency values for electromagnetic radiation. You better remember in angstrom. They are asking in angstrom only. See, for visible light, the wavelength is between 7,000 to 4,000 angstrom. For radio waves, it is greater than 10 raised to 9. So this is in the order. They have the highest wavelength, the radio waves, isn't it? They will have the lowest frequency. It will be less than 3 into 10 to the power 9. You make some funda and you remember these values. How you remember these values? See, for radio waves, it is the highest, right? 10 raised to 9. Then go on. 10 raised to 9 to 10 raised to 6 microwave. Again 10 raised to 6 to 10 raised to 3 infrared. There's some in, okay, whole number if you want to remember, or you just remember the 10 to the power. Okay. Again visible 10 to the power 3. The range is only 10 to the power 3. Again ultraviolet, it is 10 to the power 3 to 10 to the power 1. Again X-rays, it will be 10 to the power 1 to 10 to the power minus 1. Gamma rays, it will be less than 10 to the power minus 1. Like that you remember. Okay, you remember in order, it will be easy for you. Actually, I am not giving you energy values here because it will be too much. I don't want you all to get in trouble with the too much of values. Okay, only thing is that you just remember that the gamma rays and X-rays, they have the highest energy. The radio waves, the microwaves, they have the lowest energy in the electromagnetic spectrum. One more funda I have here. See, for visible light, I gave you Vibguire. I told that the wavelength is increasing, right? In the same manner, see, you can use this ultraviolet as violet. The wavelength will increase. Yes, it is increasing. Okay, ultraviolet to again visible light, the wavelength is increasing. 4,000 to 7,000 it is becoming. Like that you can remember. So these values are very important for you all. You have to remember this wavelength values at any cost, because any question comes from this only. Okay. And also you have to remember the order of this electromagnetic spectrum. When I was writing a competitive exam, the way I remembered, I am telling you, maybe it will help you. What I did is, in the middle there is visible light and in the right hand side there will be ultraviolet. This I know because of the Vibguire. Okay. And then above the visible light there is RMI. I remembered the first letters. Radio R, microwave M and infrared I. This RMI I remembered, this abbreviation. Then in the right hand side, I remember it is easily, right? It is easy. The X-rays and the gamma rays. So this RMI will help you remembering this order. Okay. Now let me talk about all the expected questions. I have gathered many expected questions, and believe me, any question will come from these questions only. The first question is, identify the medium required for electromagnetic waves to travel. I am sure you all know the answer. Yes, it will be none, because it can travel through vacuum also. Next question is, electromagnetic waves are produced by, of course they are produced by accelerating charges. Next question, to which part of the spectrum does electromagnetic waves belong if the energy of the wave is of the order of 15 keV? Actually this 15 keV means it is for X-rays. Here you can actually find the value of energy using that formula of E is equal to h nu. The frequency nu is inversely proportional to wavelength, right? So you know the value of frequency, you can find it out, but there you will have to include the speed of light, which is 3 into 10 to the power 8. Okay, so little bit of calculations will be there. By using that formula you can finally conclude that the answer is X-rays. But I would suggest you don't do all that. Just remember these range. See here, X-rays have a 0.1 keV to 100 keV energy, whereas gamma rays have energy above 100 keV. Okay, and infrared and UV rays are lying between X-rays and gamma rays in terms of energy, whereas in between infrared rays and UV rays, if you want to understand, infrared rays start from 0.001 EV to 1 EV, whereas UV rays start from 3 EV to 30 EV. Okay, just have a idea about this range. This will help you, because 15 keV will lie between 0.1 keV and 100 keV, right? So our answer is X-rays. Okay, in case they were giving you something else which is less than 1 EV, then you would say it is infrared rays. Okay, if they would have asked the energy which is less than 30 EV but more than 3 EV, then you can say it is ultraviolet rays. Okay, if energy is more than 100 keV, then obviously your answer will be gamma rays. So this thing is a safer thing to remember. Okay. Next question, which of the following rays are not electromagnetic waves? Of course, we have seen the electromagnetic spectrum, right? They are beta rays. Beta rays are not then in the electromagnetic waves. Next question. Which of the following has a minimum wavelength? Of course, they are gamma rays. Which among the following has the maximum penetrating power? They are gamma rays because they have very small wavelength. Which have small wavelength and which have high frequency, they will have more penetrating power. More frequency means they will have more penetrating power. Less frequency means they will have less penetrating power. Okay. These gamma rays, they have more frequency, so they have maximum penetrating power. Which of the following is called heat radiation? It is called infrared radiation. Then which of the following are not electromagnetic waves? Of course, beta rays. This is a repeated question. Next question. 10 centimeter is the wavelength corresponding to the spectrum of? Yes, it is microwaves. The structure of solids is investigated by using, I told you, right, X-rays are the ones which can penetrate through a object. It can be a solid, it can be your body, anything. That's why people use this X-rays in investigating the structure of the solids, especially the crystals. We call it as X-ray diffraction. So much of research goes on using this procedure. Next question. The ultra high frequency band of radio waves in electromagnetic wave is used in? It is used in cellular phone communication. Next question. The waves used by artificial satellites for communication is? Of course, it is microwaves. Why they are using these microwaves for satellite communication? Because microwaves can actually pass straight through the atmosphere and they can easily connect antennas on the earth to the satellites which are present in the orbit of the earth. Okay, so the connection between the antenna of the earth and the satellites which are actually in the orbit of the earth, this can be done easily by microwaves. Okay, because they can pass straight through the atmosphere. Then next question. Which of the following electromagnetic waves is used in medicine to destroy the cancer cells? So the answer to this question should be gamma rays, because gamma rays are nowadays used as medicine to treat the cancer cells. So these questions, they are from your old question paper of HSTR. The question is that the electromagnetic radiation which is the cause for greenhouse effect, it is infrared radiations actually. What will happen is, from the sun the light comes, right? Then whatever the things which absorb this light, no, they reflect also. But what are absorbing is, they are the causing this greenhouse effect. Okay, that's why infrared radiations, they are harmful. Next question is that the wavelength range for gamma rays is. This is an assignment for you. You have to give the answer for this question. Okay, that's all for this class. I hope that this will help you a lot. Please watch it, make notes, and let me know how you find this class. Whether you found it good or bad or fast or slow or whatever it is. And also please do like, share and subscribe to my channel. And let's meet soon with the next video. Okay, bye.